All right, so yes, today we're going to learn about the, as you can see, the geomagnetism. All right, this topic is, the calculation and all that part is very easy in my opinion. But during the time when I was in the school, this was the most difficult topic I have ever come across in terms of the understanding. If you look at the very basic idea of the geomagnetism, it will give you the idea of what and why the magnetic field in the earth core will appear, and what is the basic reason for that magnetic field, and what is the basic idea of the magnetic compass and how to use it basically. So maybe you have come across a few couple of names, like for example, if I look at this one, number one is the, for example, the uh, angle of dip. This term, maybe you have heard this term. Number two is the horizontal magnetic field. Horizontal magnetic field. And number three is the uh, angle of declination. Angle of declination. Okay, so if you successfully understand these three topics, then you'll be able to understand everything related to geomagnetism. All right, so before we proceed, we'll take three tiny classes. In one class, we'll understand about the very basic idea of angle of dip. In the second class, we'll understand about the horizontal magnetic field, this part. And the third class, we'll understand about the angle of declination. Right, so before we proceed, we need to understand why this magnetic field inside of the earth even occur. Okay, so for example, you can see this diagram, right? There are a couple of theories are available in the market to explain the magnetic field inside of the earth. Right, so for example, this is the earth, you can see, and all these tiny and huge little dots, as you can see, they are the molten charge inside of the core of the earth. As we know that inside of the earth the temperature is very high, and as this temperature is very high, so the metals will present in terms of charges. For example, the iron charges, magnesium charges, the manganese, the lead, and all the other charges, all the other metals reside inside of the earth core in terms of charges, right? For example, in this one here, you can see that couple of different colors. I have chosen the warm colors. That is why it is representing that the temperature inside of the earth is very high, and that's why I have used only the warm colors. All right, so now as you can see here in the right hand side, I have drawn the sun. Okay, so the sun, if sun is in this side, so the sunlight are coming from this side. So as the sunlight is coming from this side, that means the right hand side, the diagram here is for the day. Okay, for example, if I take the highlighter and color this part, and this is basically the day, right here. You can observe that in this part there is a day, and on the other side, where the sunlight can't reach, this part is night. So here I have written that this part is day and this side is night. So as we know, the sun rise in the east, so that's why I have depicted here the direction east in this direction and west in this direction. Now as we know that the earth rotates from west to east, so the direction of the rotation is in this direction. All right, so as this direction of rotation, you can see that means the molten metals, the metal ions inside of the earth core, they are also rotating in the same direction. All right, so now depending on the density of the positive charge and the negative charge, the positive and the negative charge are also rotating with the same manner from west to east. From west to east direction, all the molten charges, they are also rotating. All the plus charges and also the minus charges, they are rotating basically. So if the charge are rotating in a circular pattern, so basically they are constituting current. So when they are constituting current, this will basically behave as a coil of current, right? So when we are talking about the coil of current, the very first idea that come into our mind is the solenoid, right? So this is the structure of the solenoid, as you know, and if you know the structure of the solenoid and the direction of the current, you know that instantly the magnetic field inside of the solenoid become intense at the axis of the solenoid, and the magnetic field lines, the direction of the magnetic field lines, you know that this is the direction of the magnetic field lines, right? And there are no magnetic field lines that lies outside of the axis of the solenoid. All right, so you know that this is the direction of the magnetic field lines. They come out of the north pole and they go inside of the south pole. In the similar pattern, the all these molten charge, when they are rotating with the rotation of the earth, the molten charge will constitute a current, and this current will constitute the magnetic field which is responsible for the earth's magnetic field. This is the most digestive idea of the earth's magnetic field, right? So there are a couple of more ideas are also available in the market. The one of these is the ionosphere concept. The ionosphere, that means the atmosphere around the earth, is also rotating with the earth. And when this ionosphere, for example, if we talk about the ions are the present around the earth, so that ions are also rotating with the earth. So when these ions are also rotating with the earth, that means also they are producing the electric current, and this electric current is also constituting the magnetic field, and which is basically also in the north pole to south pole, and all the magnetic field lines will constitute in the same manner. All right, so this is another definition of the earth's magnetic field. And you can say that if someone asks you, so what is the reason behind the earth's magnetic field, you should say that molten metal, they are rotating around the earth's axis, and for that reason there is a current is constituting inside of the axis of the earth, axis of the rotation, and from there one magnetic field is basically generating. And also there is also some part of the magnetic field due to the earth is also responsible for the charge charge those are present in the ionosphere. All right, so this is the basic idea of the earth's magnetic field. All right, so now this is the end of the introduction of the geomagnetism. Let's move on to the next class.